This video is covering topic 3, which has been discussed in week 3, 4, and 5 of semester 2. Now, I purposely showed these, what we talked about in the previous video, because these are what helps us with looking at the circumcenter and the incenter. And so let's first look at the circumcenter. And so the circumcenter is the perpendicular bisector of a triangle intersect at the circumcenter. So here, right over here, is actually the perpendicular bisector as to what it looks like. So in other words, we would have like 3 of these isosceles triangles. So when you think of circumcenter, don't think of only the perpendicular bisector, but also the isosceles triangle. And then that way you would be able to see the sides that are congruent, or the legs of the isosceles triangle. The incenter, this matches up with the incenter, and you notice that it's in the shape of a kite right here, but we say that the angle bisector of a triangle intersect at the incenter. So in other words, we would have these, the kite shape right here, and this would end up being the incenter. This would end up being the circumcenter. So that's the reason why I was wanting you to be able to see this. So circumcenter, isosceles triangles. Incenter, it's the kites, and you always recognize the angle bisector on the incenter. The next one is the medians of a triangle intersect at the centroid. And so remember, median is where we have the triangle go from the midpoint to the vertex. And so this is the midpoint, so midpoint to vertex. And so that line that I just drew is the medians. And so the centroid has 3 of these medians, and that part where it intersects in the center, we call it the centroid. The altitudes of a triangle intersect at the orthocenter. And just remember, altitudes is perpendicular to the base, and it's not bisecting the side, it's just 90 degrees from the base. So it's basically the height of a triangle. When we figure out base times height divided by 2, the height has to be perpendicular to the base. If Z is the circumcenter of triangle STU, and we have SY, TZ, and ST with all these values, we're going to find each measure. So remember, circumcenter is perpendicular bisector and isosceles triangles. So each of these is a perpendicular bisector here. So if it's a perpendicular bisector, then it is, the midpoint is here, splitting this into 2 equal parts. And then also remember isosceles triangles, so that you could see the sides that are also congruent. So the legs of the isosceles triangle, here's the other isosceles triangle. Here's the other isosceles triangle. So let's go ahead and let's put in our values and start using the definition of a circumcenter. So it states here that SY is 19. So if this length here is 19, then this length is also 19. TZ is 21. So this length is 21. And so these would be all the legs of the isosceles triangle. So this is 21 and this is 21. And now we have that ST is 30. And so remember that if this length is 30 and this is the midpoint, then it splits up into 2 congruent lengths here. So each length is going to be 15. Now, by using the definition of circumcenter, I think we're ready to go ahead and see if we can solve the rest of the length. So we have that SZ. So here is SZ, and we already specified it to be 21. YU is right here, and we have it specified as 19. And WT we have right here, and it's 15. Now the length of ZY is going to take a little bit of work. And since we know that this angle is 90 degrees, then we have a right triangle here. And so we need to figure out the length of this leg. We know that this leg is 19 and the hypotenuse is 21. And so whenever we use the Pythagorean theorem, it's going to be hypotenuse squared minus the leg squared, all under the square root. And so our final answer for ZY is going to be 8.9. So just remember that circumcenter, it deals with the perpendicular bisectors, and it also deals with isosceles triangles. G is the circumcenter of triangle ABC, where AG is 6x plus 1, GC equals 9x minus 11, BC equals 38, and we need to find out what is the length of GF right here. So we got to do a little bit of a strategy here. We've got to first figure out what the value of X is, and if we've got AG and GC, so here's AG and here's GC, and we're talking about circumcenter, that is an isosceles triangle. So those sides are congruent. And if they're congruent, then we would set them equal to each other. So let's go ahead and solve. And so now we know that X equals 4. Again, we got to stay focused with what we're looking for. We're trying to figure out what the length of GF is, and GF is actually right here. So if we know what this length is, and then we also say that BC is 38, so now that we plugged in X, GC is actually going to have the length of 25 right here. And so since we're given that BC has a length of 38, then we've got to figure out, okay, well, if this length is 38, then this divides into two equal lengths, and 38 divided by 2 is 19. And so now we have our right triangle with a hypotenuse length to be 25 and one of the lengths to be 19, and we've got to figure out what GF is. And so now we use the Pythagorean theorem. This is the hypotenuse squared minus the leg squared, and we take the square root of that. And when we put into the calculator, the length of GF is approximately 16.2. And so now we have, if V is the end center of this triangle where QT equals 5, VU equals 7, and PV equals 29, we're given side measures. And so remember, end center has two things to deal with. It bisects each of these angles on the triangle, but also it creates the shape of a kite. So since we're looking at side length, then we could see where the kites are here. So let's look at this a little bit closer. It says that QT is 5. And so if we have the shape of our kite, now this one looks kind of strange right here, but if this is 5 here, then this length is also going to be 5. Now VU equals 7, so here's VU, which is actually the nose of the kite here and here. So if we've got VU to be 7, then this length is 7, And this other length is also 7. And then we have the length of PV to be 29. And so let's see if we can answer the questions as best we can. SV equals, well, here is SV, so SV is 7. QS is 5. Here is QV, and it's going to take a little bit of work right here. So here's my right triangle, and if you're having a hard time figuring out where the hypotenuse is, it's opposite the right angle. So this length, QV, is actually the hypotenuse, where we have the legs of the right triangle to be the length of 5 and 7. So we go ahead and set it up in the Pythagorean, using the Pythagorean theorem. So we have 5 squared, which is the leg, plus the other leg, which is 7 squared, and we take the square root to get QV to be approximately 8.6. We're also going to have to do a little bit of work to figure out the length of PS. Again, here is our triangle right here, and here is the hypotenuse, and here's the leg. And so by using the Pythagorean theorem to find PS, it's the square root of hypotenuse squared, which is 29 squared, minus the leg squared, which is going to be 7 squared. So we put it into the calculator to get PS to have the length of approximately 28.1. One of the things I'm wanting you guys to recognize is, why is it that we were adding and why is it that we were subtracting? Well, the reason why that we were adding using the Pythagorean theorem is that both the 5 and the 7 is the leg. So we were trying to figure out what the hypotenuse is, which is QV. And so on this one, we had the hypotenuse, and so we would take 29 squared minus 7 squared minus the leg. So make sure to understand how to use the Pythagorean theorem as to when to add, which is both the legs squared, and when to subtract, which is hypotenuse squared minus leg squared. All right, so I'm going to go ahead and end this video. So this completes only the first part of topic 2, and so the next video will be the second part of topic 2.